more effective and efficient and elegant test team. Of course, that is a huge part of it, but also so that you can avoid these kinds of really, really unpleasant scenarios that can occur. Now, you might say, well, Rex, it's work. Work is work, and work doesn't always have to be fun, and why do I care if people are smiling or not about the results of my work? I got a job to do. Well, as a consultant, I get called in a lot of times when organizations have problems. Now, I also get called in to help organizations implement improvements, and that's not related to a problem necessarily, but I also do get called in when there are problems. And I tell you, a lot of these problems really have to do with this divergence, and then divergence of objectives and opinions about the objectives, and then followed naturally, as day follows night, by conflict between the groups. And that is never good for the longevity of a test team. I have not seen that work out real well. And when the test team gets into conflict with other major stakeholders within the organization, it's often the test team that ends up being given an invitation to find work elsewhere. So, it's really, really something you want to avoid. So this not only matters to your stakeholders, but it also, if you like your job and want to keep it, it does matter to you. Okay, so let's talk about objectives, and we'll start with the external objectives, externally visible objectives. And I don't have time to work through all of the possible metrics that could be identified. One of the services we provide our clients is working with them to come up with metrics programs for their testing and quality. And there's quite a few that can be derived, and it depends obviously on the stakeholders and their objectives. So I want to work through an example here to demonstrate the process, to demonstrate how it works, where these objectives come from, and then where the metrics related to them will come from, and how we would get to setting goals about those and so forth. So I just kind of went off on being bug obsessed, and had a sort of a rant about that, but I don't want to denigrate the importance of bugs. So I'm going to use that as an example. Let's suppose that some of our testing stakeholders have identified finding bugs as one of the key objectives, particularly important bugs. So there's some number of stakeholders that said, yeah, one of your objectives, the test team, find bugs. So there we go. We got an objective. Find bugs, especially the important ones. All right, cool. That's a good objective. That's something that we can look at. So let's look at effectiveness and efficiency of the externally visible effectiveness and efficiency here. So what kind of questions would we want to be able to answer about finding bugs, especially important ones? Well, what percentage of the bugs delivered to us do we find? This is how effective are we at finding bugs, right? What's the answer to this? What percentage of bugs do we find? Now, we're asked to find especially the important bugs. Okay, cool. So if we look at the percentage of bugs we find that are overall and compare that to the percentage of bugs that we find, then maybe that tells us whether we're finding more of the important bugs and are we focused in the right place. In terms of efficiency, then we can look at our cost per bug found and fixed during testing compared to the cost of a failure in production, thus looking at the amount of money we save the organization through bug finding. That's nice to be not only doing things cheap, but actually doing things in such a way that we're saving more money than we cost, perhaps. We'll see in a minute. So we can come up with metrics for this. Now, I want to point out that the elegance aspect of it here, again, you're going to have to handle this in a kind of a softer way, for example, through a survey. And this is a good thing to do. Survey the readers of your bug reports, for example, and ask them, hey, what do you think of the information that's in there? Is it what you need? And do you understand what it's telling you? And ask some of the other stakeholders, how do you feel about our bug finding, our bug reporting, and so forth. Give them some statements, have them react on a 1 through 5 scale where you go from strongly agree to neutral to disagree to strongly disagree. And that's something that you would need to look at in a somewhat softer fashion. But for the moment, let's focus on the effectiveness and efficiency metrics that we could have for bug finding. Okay, so this is a fairly well-known metric, percentage of bugs found, defect detection percentage, sometimes referred to as defect detection effectiveness, or DDE. Now this is somewhat different, for those of you who are familiar with Capers-Jones's work. This is different than what he calls the DRE, or defect removal efficiency. Defect removal refers to bugs being detected and removed. What I'm talking about here is just the number of bugs detected. So the DDP, or DDE if you prefer, defect detection effectiveness, but remember, not DRE, for any point in the life cycle, we can define that as the bugs detected divided by the bugs present. So this doesn't just apply to testing. It can be applied to reviews, for example. So we could say, how many bugs did we find during a requirement specification review, and, based on the number of bugs that were present. Now, of course, the obvious thing that jumps out at you is, well, if you knew the number of bugs present, you'd just continue the review until you'd found that number of bugs. So you don't know that then. And yes, that's true. This is a retrospective metric. Some passage of time is necessary, usually, to reveal the number of bugs that were present. Now, in testing, we actually get off somewhat easier on this, because what we can do is assume that the bugs that we've missed, at least the ones that matter, will show up in production. And any bug that doesn't show up in production that we missed doesn't really matter. You have a philosophical question as to whether it's even a bug, because it doesn't seem to be related to anybody's experience of quality. So we can take the number of test bugs and divide it by the number of test bugs plus the number of production bugs. Now, you got to be clear here. I mean, we are talking about production bugs, not production failures. You can have a single bug that causes a lot of failures to occur. So they need to be, the true bugs reported into production, not just the number of raw failures that have occurred. Now, assuming that you can gather up this data, which many organizations can, it's either a research project or it's trivial, depending on whether the data for test bugs is stored in the same repository as the data for production bugs. But if you can calculate this, you find a fairly typical number is 85%, but we do find that there are some test teams that do a lot better than that. We've seen some that actually get in the 99% range fairly reliably. Now, there are perfectly good reasons why some organizations, for example, mass market organizations that are selling to diverse clientele, have much harder time getting to the 95+% range, whereas those who are testing for internal usage tend to have a much better luck at getting at that high range if they're supported by the other parts of the process. But this is a good measure of how effective you are at finding bugs. Now, okay, great. We said bug finding was one objective, but we also said that the stakeholders had identified finding especially the important bugs as particularly important or particularly critical. So this is pretty easy. If you can calculate the DDP, the metric I showed on the previous slide, then what you do is you calculate the DDP for all bugs, and then you calculate the DDP just for the critical bugs. So you just say, okay, of the bugs found in production and of the bugs found in testing that were, say, SEV 1 or SEV 2, or however you classify critical in your organization,